Hello, everyone. My name is Vijay Tinanor, and I guess we can get a little bit closer if you want to and feel more warmer. I know it's a tough time to attend a session, given that it's at 3:15. You need a lot of caffeine as well. I had mine. So what are we going to be talking about today? We're going to be talking about network resource provider. I'm here with my colleague Stephen Malone as well. He had recently presented at the Build conference in San Jose. Was it, Stephen? San Francisco. Okay. The way we want to navigate today's session is to talk about the context and motivation of why we built this resource provider. What are the needs that drove us to figure out that we need to build this kind of a service platform? And then we'll talk about the networking recap itself, so that will help you to connect the dots between the resource model that we have built and what our network infrastructure looks like in the cloud. And Stephen has got some cool demos to look at, building end-to-end applications and some templates as well. So without further ado, today's context for businesses is that they have to compete in a high-velocity environment. What does it mean? There's competition, there's customers, there's business pressure, and so on and so forth. So you have to be extremely agile. Agility means that you're able to take corrective action as soon as possible. It could be a competitive pressure, it could be a customer pressure, it could be a business pressure. So you want to run your business in a very agile fashion. And technology is an underpinning factor in running your business. You also want to be able to, have a faster time to market. These are two sides of a coin, agility and faster time to market. You want to be able to release your applications and your websites or whatever you're building as soon as possible to your customers so that they can sample it. And if something is not good, you can always pivot and repivot it over and over again. You can iterate it constantly. So that's another driving factor for businesses today. Innovation and experimentation. That's another important thing as well. You want to be able to constantly release features out so that you can try if it's working out or not, and then you can roll it back. With today's cloud infrastructure, this becomes a reality. Earlier, when you had those large data centers that you had to set up and build by yourself, this was a problem because of the large fixed cost that you had. But today you can just go sign in, you can build a large cluster of VMs, you have your network, build up an application, deploy, and enjoy the benefits. So it gives you a lot of flexibility in running your business. Another important factor is, I won't say low cost, it's a very bad word to use. I think I would call it as efficiency in running your operations, right? I'll give you a classic example. There was a time in my life when we had to install over 500 servers for a backend application. But the funny thing is, we needed it to run only for, let's say, 4 hours in a day. So I had to have a huge set of infrastructure, and not just infrastructure, but also support environment, which is power and everything else, the cooling around it, just to run it for about 4 hours in a day. So it is really not an efficient operation for me. But with cloud today, I'm talking about this 10 years back. With cloud today, all this is a reality. You can have that efficiency in your IT operations as well. The other thing is scale. Some of you have predictable workloads, and some of you not so. An example could be that you may be a retail site. You have a Thanksgiving sale coming up. So that's a predictable workload. So you can scale seamlessly anywhere between one VM instance to thousands of VM instances. That's a possibility today. Earlier, this was not a reality. To scale, you had to go add an additional servers, bring it out, pull it in. So it was not a possibility at all in earlier days. Security is an important aspect. All what happened to Sony when the movie Interview was released. So they had a huge hazard, and a lot of accounts were compromised. And very recently also, one of the premier healthcare insurance companies called Primera, they had about 10 to 11 million accounts that were compromised, which means that the credentials are lost, social security numbers are lost. So it's a very severe impact to business, and you cannot have that running your operations. So cloud gives you a lot of goodness around it. Compliance. Every country, every region has got different compliance requirements. With cloud, we kind of go through very rigorous compliance exercises, very rigorous audits to make sure that we take care of all your needs, because we all believe that you are putting all your trust in us. So we take this as a very serious need to ensure that your success is met. So those are the business imperatives for today. And there are other factors as well, but I think these are what I would call as key imperatives. So we have business imperatives. Now, how do you really go and enable your team members to be empowered to operate this infrastructure? That's a very key need. So the first thing is about the bane of contracts running for multi-years. I don't know if you have done this earlier in your life or not, but just to go and get a suite of 100 servers, the contracts that you have to run, the POs that you need to go and work with your accounting, and the SLAs that you need to work with the vendors, all that is already exhausted and gone. Today's with the cloud environment is a single-click operation. You want to get something, you go to the cloud, you configure something and start using it. Set up and tear down as and when you want. We talked about experimentation. So as and when you need something, you can set it up in your cloud, pull it down when you don't want it. Scaling, that's another important need as well. When you're talking about going from, let's say, one server to thousands of servers in a very short duration of time, let's say in a day or maybe even 30 minutes, that's a possibility today. We are enabling you to do all these things, all with literally zero cost from a point of view of labor. You just sit there in front of your mouse, keep clicking and clicking till you can make it happen. So that's another empowering aspect of the cloud, and specifically with Azure. The other important dimension that's not considered is the global reach. We operate in 19 regions. It pretty much covers the geographies across the globe. So imagine that you can sit here and operate your applications or your environment, let's say in China or Australia or wherever be it. I'm sure many of you relate to this, how difficult it is to go and establish an infrastructure overseas and try to maintain the SLAs and keep the constant communication on. It's a real headache. But with cloud and Azure, we make that possible as well. Building high availability applications. This is another advantage. Just with the click of mouse buttons, you can build overnight your applications to be highly available. We've got all the necessary components to make sure that can be instrumented. One of the recent announcements we made was the on-premise cloud infrastructure with what you have, and also the Azure public cloud. We have something called the Azure Stack that was recently announced. What it really means is that we have taken Azure, the code that's running in Azure, with all the scale, with all the redundancy, the failure tolerance, and so on and so forth. We're taking all that code and making it run in your own private data centers, because some of you have those unique needs where you need to be running it on the public cloud as well as your on-prem. So we made sure that we take all this environment and we are able to run it in the cloud, on your internal cloud. More importantly, we have the same consistent management interface. So if you're going to create a virtual network in the public cloud, you will have the same experience in creating the virtual network in your on-premise. So it is a huge advantage for you as you are building your solutions. The most other important aspect is to automate. Today's environment, you want to be able to automate things. Stephen can show you some templates which basically enable you to create an infrastructure that's huge, a multi-tier application. And if you want to launch that in a different region, all you need to do is change one parameter and redeploy. Just change one parameter, open the file, change the parameter, and redeploy. So that's a huge advantage, and you can keep this running over and over again. Many organizations have environments such as dev test, where you like to run a dev environment in the cloud and test environment in the cloud. So those possibilities are a reality today. Switching gears, I want to talk a little bit about Azure Resource Manager. So we talked about business imperatives. We talked about how we empower you as IT personnel. What is also important to understand is what is the infrastructure that's enabling you to do this. There's something called Azure Resource Manager. We released this in 2014 spring. What it essentially is an infrastructure to be able to build this container of resources. So Azure resources are basically units of, I would say, compute, storage, and network, which you can stitch together to create your application. So what you do is, let's say you want to launch a retail application. You have your web front end. You have the services that run in the background. And you also have your database tier. So you have to pull this all together in one container, and you can deploy it to Azure. So that's a huge advantage for folks, because you can set up, tear down, you can scale, you can assign very granular RBACs, you can assign a lot of logging, you can do a lot of tagging as well to be able to tag these resources. So it gives you a lot of advantages. The ARM infrastructure, as we call it, can work with multiple resource providers, for example, like compute, network, storage, and many others. Event Hub, and so on and so forth, to help you and stitch all these complex applications. One of the key advantages of Azure Resource Manager is something called templates. Now, templates is a fantastic transition point for IT personnel. It's a fantastic transition point. You don't have any programmatic experience there, besides the fact that we also support other programmatic interfaces. A template is basically a declarative structure. So you prescribe what a VNet is, you prescribe what a subnet is within a VNet, you prescribe what IP addresses that you have inside, and you can compile this template and deploy it. It's as simple as that. And the other important part of templates is the fact I was talking about earlier is the parameters. You could basically have multiple parameters that you can inject into the template so as to customize it very rapidly. So Azure Resource Manager provides you with all this infrastructural advantages to go and build your applications. So it's essentially a container. So before we go and talk about the network resource providers, it might be good to talk about what Azure networking is all about. Let's say you want to run your applications in Azure. There are three broad compartments you need to look at. One is, how do you go and reach Azure? Number one. Okay, now you've reached Azure. How do you go and build your network infrastructure within Azure? That's the second category. The third category is that you've got your infrastructure in Azure. You're able to reach Azure from the public environment. Now, you also want to connect to your backend on-premise. So that's the third bucket. So we have basically compartmentalized our technology resources into three broad areas. So you go to Azure, you create a virtual network, which is like your own physical network on-premise. You create various subnets within this virtual network. You deploy the resources within the subnet. And if you want to provide protection and security boundary between the subnet, you define what is called the network security groups. So we talked about virtual network, we talked about subnets, we talked about network security groups. So you have your application running in Azure. That's good. Now you want to expose this application to the outside world. It could be a blogging application, it could be a retail application, it could be anything, a social network that you're building. So you need public IP addresses. So you go and buy these public IP addresses. And once you have these public IP addresses, they can be either reserved, when you say that you would like to reserve this public IP for the duration that you want to have. You can assign a domain name. So it could be www.contoso.com. You assign a domain name to this public IP. You can keep it dynamic as well, if that's how you prefer to have it. Now that you have a public IP, you have this infrastructure, the next big thing you want to do is, as you grow, you want to scale. You add a load balancer. So you have your public IP, you put a load balancer behind it, and you can put a lot of servers that you can scale behind the load balancer. So you start off building the virtual network, you compartmentalize them into various subnets, you connected them to the public outside world using the public IP, and now you want to scale, you add the load balancers. So you have load balancers, public IP, virtual network, subnets, network security groups, and so on. So you all have this running, and now you want to also have some kind of logging capabilities with your on-premise infrastructure that you have. You would like to have your IT professionals to look at what's going on, who's accessing, and so on and so forth. So you can also connect your on-premise using the various network components that we have, like site-to-site or express route, or a combination of both. So that builds the entire topology of networking components within Azure, and it gives you a lot of flexibility. Now, a good transition point is to introduce the Azure Network Resource Provider. Earlier, what used to happen was that we had all these things that we talked about, the so-called nouns that we used, were a monolithic model. What it really means is that you build this application in one such configuration file and you deploy it. Okay, that's good. Now, you want to go change a subnet address. What do? Well, you need to make the change and you need to redeploy it again, which means you may have to restart your application. I don't think that's a good experience, both from a business standpoint and from your end consumer standpoint. So this was a very conscious decision that we took to make sure that all the resources that we talked about, which is virtual network, the subnets, the network security groups, the public IP, the load balancers, internal, external, and the VPN gateways. These are the essential components that are used to compose your applications. We elevated them as top-level resources. Now, you can go and configure them independently and autonomously. And the way they connect to each other is through references. So we made this possible with the network resource provider. And that's what it means by a loosely coupled network resource model. You have these resources. Now you want to be able to manage them. So you have REST-based APIs with parameters that are very intuitive for you to understand. So we heard a lot of feedback that some of these parameters are very arcane even to read about it. So we made it very intuitive for you to understand. We want to basically demystify networking in Azure and make it as simple as possible. We also have support for templates, which is very important for you. You build a template once, you promote it into your GitHub, you can't deploy it, you can do all the operations to automate. We also have support for RBAC, so you can give very good RBAC control. We'll talk about that in a couple of minutes. And we also have an imperative style for management. What imperative means is that you can have various other programming interfaces. So we've got SDK support, which is for C#, we've got Node.js, we've got Java, and we are constantly extending this pipeline. We also have PowerShell. We also have Azure CLI for Linux workloads. So we are constantly investing in all these management surfaces so that you can work with any amount of flexibility that you want to have. We talked, is it quite visible to the back? Can you see these diagrams? Okay, it is hard, okay. My friend Jeff here says it is hard indeed. What I wanted to expose here is basically a multi-tier application resource model. This is how it looks logically. From a composition standpoint, this is how it looks. And you see all the important elements here. Towards your left top corner is your storage. At the bottom left, you have your compute. And the rest is all networking. And you see all the important ingredients that we talked about. Your virtual network, you have your subnet, you have your network security groups, you have your public IP, you have your VPN gateway, you have your traffic manager, and your domain hosting service, and so on. So it is essentially a very well-composed model, very loosely coupled, very easily associatable. And you can configure all this using templates as well. So we want to talk about RBACs a little bit. This has been a very long-standing request from most of the IT folks that, the most essential ingredients is to be able to offer a role-based access control, because we have a lot of people in our orgs where some of them are users, some of them are contributors, some of them are business owners that have different levels and needs when it comes to managing and using these resources. So we have built in the role-based access control, and the important part of it is so granular that you can go all the way to the resource level. What it really means is that you have a subscription level RBAC control. You go to the resource group RBAC control, which is the containers that we talked about. And within the resource group, you have various elements that you use to go stitch and compose this application. Each one of these resources can have unique RBAC controls, and you can assign various users to go manipulate it. And there are various advantages to this. Let me give you a classic example. So there are two ways of how you can manage, build, and use your application stacks, right? You can build your application stack as a vertical, as the application tier, the mid tier, and the database tier. You can build your template like that and deploy it into a resource group, and it starts working fine. Or you can say that I've got different parts of the companies managing different stacks. So you could have your network team managing the network stack. They can have a different template that goes across the org. You can have the database team managing the database stack. So they have a different template to go manage that part. So you can segment it in any dimension that you want to. You can either have units that are using it end-to-end, or you can segment it based on layers and deploy it differently and manage it differently as well. So it gives you a lot of flexibility. The next important thing that we were pointed on was the ability to tag. So this was not available in the earlier releases that we had, but now we can tag up to 15 different tags. Now where this is useful is you have put in a lot of infrastructure, you have invested millions of dollars. Now you want to be able to track this with various dimensions. It could be based on departments, it could be based on business heads, it could be based on application. So you can add up to 15 tags on each resource, and you can do all kinds of slice and dice on the data. It gives you a lot of flexibility. We're getting a lot of good reviews about this, and this is a very useful tool to have. As we talked about earlier, we've got various surfaces. We talked about the REST API surface. It's very, very intuitive to use. It's very easy to use. We talked about the PowerShell as well, the Azure PowerShell. It's a continuation of the previous products. We have Azure CLI for the Linux workloads. We have the Azure portal. You will see very rudimentary implementations on the Azure portal, but we are investing heavily on it. This is primarily to ensure the transition happens very smoothly into the DevOps world, as you are IT professionals right now. We are also having templates. Templates is, again, is a very important tool to invest in. It's a little bit of learning, but it's extremely useful and very important. The only thing that's going to be an obstacle, if you will, is the JavaScript notation that you use, the JSON object notation. Once you understand that, it is very trivial to stitch this with the Azure template definition. It's very, very intuitive. It's very, very easy to do it. Then, of course, you have the SDKs. You have the .NET, you have JavaScript, Node.js, and, of course, Java as well. And we are constantly adding more and more surfaces. It doesn't stop here right now. You're thinking about Python and PHP and everything else. We will be adding more surfaces onto this. So what we'd like to do now is probably do a little bit of a deep dive. And Stephen has got some good demos as well to talk about. And I'm hoping that all this will be a good takeaway for you guys, and so that you can give us good feedback after the session.
Thank you, Vijay.
Yep.
Okay. Okay, 1 second, I'll log in here. Okay, let me just switch over to my laptop. Okay, ARM templates. Has anyone used them yet? No? Okay, ARM templates are awesome. They allow you to model an entire application in a file and then submit that file to Azure, and it will then create that. The ARM template file is obviously, to start off with, it's a JSON file. And it has a number of key areas, which are parameters, variables, and resources. The resources section is an array of any number of resources you want, of any different type within ARM. So we're not just talking about compute, storage, and network. We're also talking about Azure websites or SQL database. Any of these things can be specified in the same ARM file, in the same template file, excuse me. For parameters, just to show, we can pass in name parameters into this template. And then in variables, we can do things with those parameters, and we can create new variables to allow us to implement some custom functionality. For example, here, I'm taking some of the parameters and I'm making object names out of them by concatenating and so on, which is really useful for making sure that you're keeping the complexity of your templates down to a minimum. JSON is really the language underneath Azure Resource Manager. Our REST APIs for networking, compute, storage, and all of the rest are all implemented using JSON. And so JSON is really the underlying medium. If you don't know JSON, don't want to look at JSON, that's fine. You can use the imperative command lines, you can use the SDKs, you can use Portal. But if you want to use templates, this is the way to go. Within this, we see very rich Visual Studio support. So on the left-hand side, as part of the Azure SDK 2.6, I believe, I have a JSON outline. And in this, I can add new resources to the template file I already have. On the left, we see a library of options that I have available to me. And I'm not going to do this, but then this will insert the JSON stub into your template file to allow you to create that resource, which is awesome. Cool. So this particular template file, if I can explain, is modeling this. This is a public load balancer with firewall, with network security groups, which is a virtual firewall, and it has 2 web servers behind it. With the web servers have network interface cards that have private IPs, and the load balancer has a public IP. We have 2 access routes into the servers. We have the load balancer with port 80, load balancing across the servers, and we have ODP access enabled as well. ODP is enabled in this scenario through inbound NAT rules on the load balancer, and port 80 just gets load balanced normally across the backend set. So if I skip back, excuse me. Okay, so within the template then, we have a look down here at the resources, and the resources in this template, we have storage accounts up here, availability sets, these are for the VMs, and then we go into networking. We have network security groups, which is our virtual firewall. We have a virtual network, and we have network interfaces. We've got 2 of them, one for each of the backend web servers. And then further down, we have a public IP address, we have a load balancer, we have virtual machines. And this is where it gets interesting from an end-to-end application point of view. We have virtual machine extensions. I'm just going to expand this so we can have a look at this. Well, 2 things to note here. And the first one I could illustrate with any of the others, but we'll just do it here. If we see here, we see a depends on notation within these virtual machine extensions. This enables us to specify that these extensions depend on the VM that they're going to extend, that they're going to implement some additional behavior on. And we see that this extension is a PowerShell extension, and it's of type DSC, which is desired state configuration. This basically allows me to start up a VM, and then once the VM is started, then have PowerShell run DSC scripts inside that VM before it gets given to me, and so that I don't have to do the deployment, I don't have to ODP into it, I don't have to do anything. So I can configure the package or the configuration as I want it, which is awesome. We see other things, such as if we look at the virtual machine and expand its dependencies, we see a bunch of these. It has a dependency on the availability set, on the new storage account, and that's for the VHDs and for the NIC. So I am going to show how this is run. Excuse me. Okay, so here, for those of you who haven't seen Azure Resource Manager before and the new APIs, in PowerShell, we have a switch mode so that the new stack and the old stack can coexist in parallel without any interactions between the two. They made a switch. So run this first, then add the account, set the subscription, and then we're ready to run the script. I've already done the first 3, so I'm not going to do it again. And then this is the interesting bit. This takes the template file I have on disk, and it specifies where I want to create it in East US. Gives it a name prefix. This is going to be used by my variables to create the names for all the objects. And then various other things like the storage account name, the public IP DNS name. We'll look at this again. And administrator username and passwords. And then modules URL. I'll look at that in a second. I'm going to start running this. It's going to take around 25 minutes or so because of the DSC, starting IIS and installing website. So we'll check back on this. And what we see is that immediately, once it's been accepted by Azure Resource Manager starts decomposing the template into a dependency tree and figures out which ones are dependent on which other ones, and then it starts instantiating the base dependencies. But once it has the base dependencies done, it goes on to the next one and so on. Where it can parallelize, it will. It will parallelize as much as it can across all the resource providers, so not just in networking. If it can parallelize networking and compute requests, it will. If it can parallelize VM creations, it will. So you can have 50 VM creations going on in parallel at the same time, which is a huge difference to the kind of throughput and performance you see with the current stack. Okay, so while that's running, I'm going to switch to the Azure portal just to show, like, the JSON templates are really awesome. There is a community library, which is on the azure.com, azure.microsoft.com website. We go to community and then templates. And then we see a list of templates that are all there ready for use. These are coming from Git, and they're showing up in this list automatically. And if I search here for sample templates, I see quite a few. One is there, which uses DSC as well, which is awesome. A different one, for example, does, see if I can spell, SharePoint. 3VM SharePoint deployment, which is awesome. But just to quickly show you how this would operate, if you go in here, you click on one of these templates that's freely available to you on the Azure portal, you get a Deploy to Azure button. And this is coming directly from GitHub. And you can see in the URL, it's very, very small at the bottom, that it is actually referencing the files on GitHub. So we click on this and go through a couple of redirects. Okay, so here we see the schema, the template that is creating this, this deployment. And all we do is say, yep, that's fine, we'll accept that. And then we get the list of parameters. So here we can specify where we want to create this and all the parameters required for this. And then at the end of it, we would just click deploy. And then it would go off and create that on the portal into your subscription, which is all pretty awesome. Okay, so I'm going to switch back now to the presentation. Okay, sorry, that's the one we just did. Okay, so the template library on azure.microsoft.com has quite a few templates already. Some of them are shown here. There's Docker templates, there's SharePoint, there's SQL Server, Apache, MongoDB, Django, and there's quite a few more. And we're expanding this really on a daily basis. There's other templates also available within PowerShell, within a template library within PowerShell. So between the two, there's quite a large collection of items available. Okay, so we talked a little bit about the object model here for the new ARM NRP API. Can you see this? Do we need to zoom in? Okay. We'll try, okay, wrong machine. Okay, so we have Microsoft Storage, we have Compute, and we have Network. On the Compute side, we have virtual machines, availability sets, and extensions, and we had a look at them a second ago. On the Network side, we have quite a few objects. We've got network security groups, virtual network subnets, load balancers, and so on. There's quite a few. What is very interesting about this is, one, that this doesn't exist in isolation. There's other resource providers for other objects within Azure, such as websites and SQL. And second is that this is very different to what the resource model we have now, or the service management interface that we have now. For example, those of you who are familiar with our current PaaS offering, when you get PaaS, you get a public IP, you get a load balancer, and you get a load of VMs. And you don't really have any control over that. You get the public IP and you get the cloud.net address and you get the load balancer, and you can't say, I don't want any of them. With IaaS, it's a little bit better, the current IaaS. You get your public IP, and then you choose whether or not you want to have a load balancer or how you want it to behave in terms of availability sets and so on. So more control, but still not total control. You're still getting the cloud.net, you're still getting the public IP and so on. So for people who want to have more sophisticated deployments, it doesn't really support them very well, or people who don't want to have any element of the above. This allows you to pick and choose exactly what you want. For example, you can have a VM with a NIC and a public IP on the internet, unfiltered, if you so want. You can have a VM sitting in your virtual network with no access to anything because you've implemented a network security group. You can have a load balancer with a public IP, sharing websites on the internet, or you can have it in a private IP within your VNet that's not accessible to the outside for a middle tier application, for example, or for your internal SharePoint where your virtual network is either protected through site-to-site VPNs or through ExpressRoute or something like that to prevent external users to get access to your internal applications. So really here, there's so much more power and so much more opportunity for you to configure things as you want to do it. And we're going to talk a little bit about network security groups and DNS in particular, and run through some more demos. Okay. Network security groups is a virtual firewall within your virtual network. You configure a network security group within your subnet, and conceptually, it is comprised as such. There's a group, and then security rules. There's also default security rules, which aren't listed here, that basically secure your subnet by default. So the default rules will prevent anybody from accessing your subnet from the outside by default, and then it's up to you to poke holes in that by overriding the default rules with the behaviors in your own custom-defined network security rules. For the network security rules, you define behaviors such as the name, description, protocol, source port, destination ports, usual stuff that you'll find in any firewall. Anyone who's ever looked at firewalls is familiar with this type of framework and priority-based rules to filter traffic. It's all pretty straightforward. Okay, click is not working. Click's working. Okay, I'm going to switch over to demo again, and I'm going to show you how we can interact with network security rules and how we can programmatically manipulate our objects in Azure through using the NRP. So the template I've provided already, the template I'm running in the background, is deployed to East US. I already have deployments to West US and West USA. West Europe and West USA using the same template. So all I've done here is I've changed the region. So these two are deployed here. This tool I'm showing now is Azure Resource Explorer, which is a preview tool and allows you to see all of your resources within the resource groups for your subscription and in a graphical format. It doesn't just cover compute storage network, it covers any resource. And we can see here, then I have sample app West Europe and sample app West USA. If I expand these, I start to see, okay, these are the namespaces, compute, network, and storage. Great, this is awesome. And if I expand network, I see that I have load balancers, I have network interfaces, I have network security groups, which is the virtual firewall, public IP addresses, and virtual networks. So expanding two of them, the virtual networks, I see I've got a subnet. Awesome. And if I expand network security groups, I see that I have two security rules, which is also cool. On the right-hand side, I see the JSON required, the JSON representation of these objects. I could use these to create new templates if I wanted to, or to create new templates, or to modify right here. This tool allows me to, if I go up to the top, allows me to put new data, to update the data right here, which is pretty awesome. So yet another way to manage this information, if you don't want to use PowerShell, you don't want to use SDKs or Portal, is to use this tool and hack away at JSON. Awesome. And then these tools, first rule we see is allowing RDP. We see the port range is 3389, 3390, and I'm putting this onto the public IP. We'll see in a second, the load balancer is then doing inbound NAT translation on that to translate the front-end port at 3389 to back-end port 3389 on one of the individual servers, and 3390 front-end is going to 3389 back-end on a different server. So key here is it's allowing this traffic, and it's got a priority. And the priority is less than the default rules, so it's going to work. It's going to poke this hole. The next one we have in here is a web rule. And this is because we've got a web server. We've got a public IP and a load balancer, and we want to host the web traffic. If I didn't have this rule, it wouldn't work. So the key here is port 80, inbound, and allow. Awesome. So just to show you the load balancer that I talked about. Excuse me. So load balancer is, there's a lot of things going on with load balancers. The inbound NAT rules is the one in particular here, which is specifying tunnels through the load balancer into the backend servers. That's fine. So I was playing around with this, and I deleted one of these rules. Not for West Europe, but for West USA. So if I look at West USA, and look at network, same thing, network security groups, security rules, I only see one rule, and it's an ODP rule. There is no web rule. So I think I'd probably expect this not to work then, if I ping it. So I'm going to go get the IP for this, which is sample app West USA, that's the resource group. I'll just name it a public IP. So this is our shell. And I'm going to get the FQDN. The FQDN for this is here. Also note here, there's a domain name enable, which is used in creating the FQDN, but and beneath a reverse FQDN. If you wanted to create a PTO record for this, we can do that. If you don't want to create a DNS record, or if you don't want to create a PTO record, that's fine. Leave this null, leave this blank, and we won't create a DNS. So unlike the current model, where we create DNS for you and create everything for you, we don't know. You have to opt in. So copy this, and I go back to this. I'm going to use a tool called TCPing. This is a tool we use quite a lot. It's not an internal tool. It's developed by somebody else, but it's pretty cool. And I'm going to, TCPing basically does the equivalent of ping, but over TCP. Ping is ICMP, which is unreliable, and there's also difficulties getting it over the internet, so this will absolutely work. So I want to ping West US endpoint on port 80. This will take a second. It's not working. This is expected, because the rule is not there. So the security rule has ODP for West US. It does not have web. So a different way I can manage my resources is with SDK. And this is the .NET SDK. And here I'm creating credentials, creating a token, and then crucially here, I am, let me just let that go away. I'm creating an NRP client, Network Resource Provider client, and I'm passing in the credentials. So let's start this off. My account is configured with two-factor authentication, so I just need to improve this. Okay, now the breakpoint is set. It hasn't actually gone anywhere yet, so I'm going to step over this. And what I'm doing here is I'm telling it to get from this resource group, sample app USA, West USA, that network security rule. And step over this. And if I look at this, it's retrieved it. This object is not null. It's got the full collection of network security rules. So if I step through this, oops, excuse me, I stepped over that, excuse me. What I'm doing here, I'm adding this network security rule to the existing list, which is port 80, which is fine. And then step over. This operation is then putting this updated set back to the server. And step over. Cool. Here, we see the response code, and if you can read that, it says OK, which is pretty awesome. And now if I switch back here, I see, OK, I've updated the network security rules. The platform has accepted this and is now applying it. I'll come back to this. If I look at the Azure Resource Explorer, and I update this to see what it says, I see that it's there. Great. So now there's a collection of two rules there, one for ODP and one for web. You see it over on the left-hand side, which is pretty cool. Now if I switch back here to the ping that I had continuously going, we see that as of about, 10, 20 seconds ago, the port is open. So this really demonstrates that we're not just talking about an API to allow you to manage your objects and so on. We're talking about a really fast API to propagate these changes in near real time. So it's not like file a request and come back tomorrow. You file a request, and within seconds or minutes, it's done. Like the lead times associated with legacy hardware, legacy configuration are gone. Okay. So let me just show. Now that this port is open, I'm going to show these two websites. So what I've actually created here. So I'm going to go back to this one. And here I have the FQDN for my West USA. I'm going to copy this, put it into a browser, and see what happens. Okay, doesn't do very much. But it does say, welcome to your web server farm in West US. So it's open, it's hitting it, and incidentally, the IS was configured, and this landing page was set using a DSC extension script. I didn't log into these servers to do this. So, cool. And if I go back and look at the other one in West Europe, we see, predictably, probably, same thing. Oh, excuse me. Okay, fine, it's all working. So I'm going to switch back to the slides now. So that was just an indication of how we can use the imperative APIs, how we can manipulate things in near real time, and how we can get a really fast response from the service. So switch back. Okay. Traffic Manager, Azure Traffic Manager, is a service that allows you to do DNS-based load balancing across multiple regions. In this, for example, you can have yourapp.com or www.yourapp.com. You can have 3 regional deployments, and you can have this DNS-based traffic manager sitting in front of it. There's 3 different profile types, and there's variations of them. The first is performance. It routes to the closest by DNS latency, so based on the DNS recursive resolver you're using, how close that is to the endpoint. The second is round robin or weighted, which allows you to share traffic between multiples in prescribed ways, such that you can have equal 50-50 between 2, or 50-40-10 if you want to flight something, and just have a certain amount of traffic hitting a certain endpoint to see how it responds, and so on. Or you can have failover. Failover is particularly interesting from the point of view of if you wanted to have traffic manager sitting in front of your Azure and on-prem deployment. So that if you normally wanted to run from your on-prem, but then if there's any issues or whatever, then failover to Azure, or vice versa. Then failover is the right way to do that. With failover or priority, there is a priority order of regions, and they can be on Azure or external endpoints. And incidentally, it could even be in Air China instance as well, if you so wished. And then it would go to the highest priority endpoint that's still up. That's cool. And then also, we have Azure DNS. Azure DNS was released or announced as public preview this week on Monday. It is our new customer DNS domain hosting offering. It is exceptionally fast. We have an edge network at the moment that is big and growing. The performance that you can get from hosting your domains with Azure is now quite brilliant. It's awesome. And it uses Anycast so that you always get routed from a customer query point of view to the closest node, the closest serving node. And the availability, because of this network and because of the number and scale that we have, is huge. The availability is awesome as well. The DNS offering has support for all the common record types, A's, quad A's, CNAME, and so on. And it allows you to bring your domain that you might have hosted with GoDaddy or somebody else to Azure and simplify your billing relationships. So then you can have your, especially if you're talking about having reserved IPs, then you can have your reserved IPs in your Azure hosted domain, or you can host your vanity domain sitting in front of, for example, a traffic manager endpoint on Azure as well. And that's kind of where we're going with this. So in terms of the object model, we have, for DNS, and this is just conceptual, we have just a name and location. It's not a whole pile that we store for DNS zones. The name is the name of the zone or the name of the domain. And then within that, we have record types. Record types exist, record sets, I should say, are a collection of names and record types. So a record set within this service is, for example, an A record type with www name. That's a record set. Or mail with MX type. That's a record set. The record set can contain one or multiple records, depending on the type. Obviously, if it's a CNAME record set, it can only contain one because there's peerless node thing. So that's pretty cool. So with that, then, we have a custom data then, custom types, depending on whether you're talking about CNAME or MX or so on, or SRV. But conceptually, this is how it works. You have records, record sets and record types within a zone. Traffic Manager then, conceptually, has location as well, the name, and the name conceptually is the relative part of the trafficmanager.net domain. So if you wanted to have my cool app, then it's mycoolapp.trafficmanager.net, and you create it with location. The routing method, which we talked about, is either performance or priority or weighted, and it also supports nested. It also supports nested profiles, so that you can create a global performance policy and then regional failover policies. So if you had, for example, a data center in Europe, as well as an Azure data center, an Azure footprint in Europe, then within Europe only, you could then load and balance between the two, and then use Azure fully in other regions. And we have endpoints. Endpoints are a set of either Azure-based or external monitoring points, deployments, that you can load balance your traffic over. So that's all cool. So we can probably guess where I'm going with this. Let's switch back to the machine. Okay, that's still up. So I've showed you that we have, at the moment, we have deployments into West USA and West Europe. And at the moment, they're using, quite frankly, not very user-friendly DNS names. And they're not, if you give a user this particular DNS name, then they're going to go to that region all the time. There's no choice in the matter. They're not going to get a very good experience if they're sitting in Europe and they're hitting an endpoint that's in America. So a way to make this more performant from the customer point of view is to put Traffic Manager into these two. So here, as it happens, I have just that. I have scripts. So at the top, I am creating a new profile. Of note here, this is creating in a resource group I've called Ignite. My relative DNS name, which is going to be .trafficmanager.net, is SMalone app. Great. I'm using weighted with TTL of 30. That means every 30 seconds I expect to get a different response. Cool. Okay, and that's created. We see the output here. Doesn't do very much. It just says, yep, that's fine. What it would do there, it would check whether the name is available. The name is available, so then it just created it. There's nothing in here yet, so it won't actually do anything. So here, I'm going to add a Traffic Manager endpoint config. And this is for the West US deployment. We're adding it as enabled with a weight of 50. We're only going to add 2. So we expect to get equal distribution of traffic across the 2. And it's of type external endpoint. So if we run this one, that's added, fine. And the next one is the same, but it's for West Europe. Run that. And here is where we actually apply the 2 adds. It adds to a local object, and then you set the object back. Okay, cool. So let me get the name. So all of that is completed. If I switch back to Bing or to IE, and I see smalone-app.trafficmanager.net, I hit that. Hey. First, you see the traffic manager provisioned really quickly. This wasn't there already. And so it added the profile, added the endpoints, and I was able to resolve it literally in like 10 seconds. And this should then rotate. So because I set a weighted policy, if I hit this 10 times or 15 times, I have to factor in TTL, because once it gets a cached response, it will cache it for 30 seconds. But then once that expires, it will roll over. And if I had set the policy to performance, then if I was in West Europe, I'd most likely get West Europe and East America and so on, which is all pretty cool. Okay, so that's great. But it's arguable whether or not you'd want to give a URL like smalone-app.trafficmanager.net to your customers. This is where DNS comes in, or Azure DNS comes in. I got this in PowerShell as well. So I have a DNS zone that is hosted on Azure that is delegated from the registrars. I can show you this here. Oh, excuse me. Which is here, which is my.org.test.net, and I put it in the same resource group, Ignite. If I look at the record set, this is for root in DNS parlance. So I'm looking for any record types of NS at the root of this zone. And I get back a collection of name servers. And they're down here, which is NS105 and so on. If I then do a lookup of type NS, my.org.test and so on, I get this, which is interesting. These servers here, which is exactly the same as I have up here. So we know this is authoritative. This is where it lives according to the internet, this DNS domain. Now I want to add a new record set. Note here, I'm specifying the zone, and I'm specifying a relative name. This is cool global app. Okay, and this is within my zone, within my DNS zone. And I'm specifying type of CNAME. Run that. Fine, all worked. And to this record set, I want to add an individual record. And because it's a CNAME record set, I want to use a CNAME. I want to add a CNAME record. All I'm specifying here, because the name is already specified by the record sort that contains it, is the target. Okay, that's cool. And now that made changes to the local object, I just want to reset that object up here. Cool. Now, I have this. Let me copy this. And let me go back to IE. And we have cool global app.mytest or mytest3.net. I'm on that. Okay. Now we've seen that we can have a vanity domain, one of your own DNS domains hosted on Azure, and you can modify records, DNS records in near real time as well, with extremely fast propagation to the edge, so that your customers can resolve those records nearly immediately as soon as they're created. Cool. Okay. So I just want to switch back to the slides now. Okay. Another benefit of Azure Resource Manager is that we're developing a consistent framework across the whole API space for Azure. Obviously that's important if you're using PowerShell, if you're using SDKs and so on, but it's also important as it allows us to develop cross-cutting concerns, such as what you saw earlier being the Azure Resource Explorer, that is really write once and use everywhere. So from our point of view, we're able to get economies of scale, so that each team doesn't go off and do this separately. And this is another example of this. With a feature to get group audit logs, then you can see who's changed what and when. As an example here, we're specifying a time, we want to see what happened, and then it tells us like what happened, and it's also supported in Portal. This gives us a good indication about if anything untoward happened, if somebody changed something that we weren't expecting, and so on. There's like role-based access control, which is what BJ mentioned earlier, is similar in that because it's developed centrally against the Azure Resource Manager, it allows you to use role-based access control against any arbitrary resource in a consistent way using standard tools. Okay. So before going there, I'm going to check on the object I was running before. I'm going to switch back to the. Okay, so this is the one we ran earlier. It is deploying into East US and is using the template that was specified. So here we see that the objects are created, it's finished. And so if we skip back to ARM Explorer, we previously saw only two. If I refresh this, I'd expect to see the third one in East USA that's going to be fully fleshed out. East US, there we go. And here we have compute network storage, and the full conceptual object has been created. Excuse me, where have we gone? There we are.
How long do you keep the network data?
Sorry, there's a question from the floor. How long do you keep the network changes? I presume it's a question about the audit logs. Yeah. I don't know off the top of my head. I would expect it to be in the order of like 180 days or so for compliance reasons. But we can follow up and we can get a definite answer on that. Okay. So we see that completed. So obviously then if I wanted to take that to the next logical conclusion, I could then quite easily add this into the same traffic manager set with the performance policy or round robin, and then I can have this regional deployment in there as well. Okay, so then to switch back to the presentation. Okay, so we talked about quite a few things. There's two main takeaways from this, is that Azure Resource Manager provides a consistent experience for you to develop your solutions. You can model your end-to-end solutions with templates declaratively. You can do that either in one template for an entire application, or you can subdivide that into multiple templates such that you can have an IT pro declaring the virtual network and the subnets and locking down permissions using ORBAC so that only the IT pro, or only that IT pro, can modify the virtual network or the subnets. And then you can also delegate permissions for like virtual machines, or delegate permissions for storage accounts or anything like that to developers, so that they can go off within your virtual networks and create their dev and test environments. So that's using declarative models, using templates. And as I said, there's a huge library of things available to you there. It's going to be increasing, and it's certainly going to be a jumpstart point for you to get the solutions you need and the configuration you want. The other way is with imperative APIs or imperative changes, and these can work together so that even if you create things with a template, then you can imperatively manage those objects. So you can add new objects to your template, or not to your template, but to your resource group that was created with a template, or you can delete them and so on. You can update them. If you reapply the template, then it resets the go state, but it only does it for objects it knows about, so that it won't delete other objects that you have in your resource group. So in that way, you can have multiple templates all contributing into the same resource group to allow you to have separation of concerns from a management point of view. You can then check those templates, if you wish, into your own source control, such that then when you make a change to your template and deploy that change, then you have a record in your own source control about what template is active. And on the imperative side then, we saw SDK, we saw PowerShell. I didn't show you CLI. I think there was a demonstration yesterday or Tuesday of the DNS with Azure CLI. But there's also support for Node.js and for Java and so on. And as Vijay mentioned, we're aggressively pursuing these other imperative mechanisms for managing your resources. Okay. And then the key point or the key differentiator for the new Azure Resource Manager, NRP and compute and so on, versus the stack we have now, is that it's up to you. You can create a comparable experience with the new stack to what we have now, or you can say, well, I don't want DNS, or I don't want a public IP, or I don't want all of these things. I just want to do it the way I want to do it. And with less features or less surface area means less risk. It's more secure. And you can leverage the libraries, leverage the templates from the community. You can create your own. You can publish them if you want to. You can put them into Git, and then they'll show up on the Azure portal, which would be kind of cool. And the template, incidentally, I used earlier on, I'm going to put that up into Git either today or tomorrow. So you can do that yourself and have a look at it. And so, yeah, if you want to create load balancers, do it. Public, private, not a problem. And we didn't cover today other features, such as virtual network gateways, but it's also a pretty cool thing. In the example, I had used inbound NAT rules to create port address translation from the public IP to the private IPs, 3389, 3390, respectively to 3389, which is fine. A different way to do that would have been to only have port 80 open on load balancer, not to use inbound NAT rules, and to use a VPN to connect into the virtual network, and then connect securely to your private IPs over the VPN. And with the addition as well, this week of Azure DNS and some time ago of Traffic Manager, there's really a very rich and complex environment for you to create the kind of rich networking topologies you want to create within Azure, and including links to virtual machines and storage and websites and whatever else. Okay, so I'm going to leave it there. I'm going to leave some time for questions. It is very important that we get feedback, so if you can fill this out, and it'll make us better. Thank you. And thank you for your time. So, any questions? Hi.
So, you talked about the programmatic interface.
Yep.
Right? So, how do you do authentication for that? I think you had shown some code and the documentation.
Yep. So the question from the floor is, for programmatic interfaces, how to do authentication? The response is that in the example I showed, I used Azure AD, and I used tokens that were given from Azure AD. So I set up an application within Azure AD, and then specifying client ID and so on. And that basically, once I specified the secrets into Azure AD service, I get a token back, and then I add that token as a header to the request that I send them through. My understanding is token is time limited, but I'm not an expert in that area, but my understanding is it is, yes.
The token can be renewed for numbers of time, but in general, after, I think it's 90 days or something like that, you're forced to acquire a new token.
Okay. So an answer from the floor was that, yes, the token renewed a number of times, but then after 90 days, you're required to get a new one. So that's awesome. So does that answer your question?
So, sorry, just to be clear, right? So, you've got an acquired token, but you can renew it.
Yep.
Within those 90 days, or after 90 days, you have to wait.
No, within those 90 days.
Within those 90 days.
Okay. So,
There's conditions to be met to be able to renew it.
Okay.
I mean, so every X amount of time you can renew it, and then you get an extension in your permission that after 90 days, it has to.
Yeah, just for the recording to repeat. So yeah, within the 90 days, we can renew it, but then if it's not renewed within 90 days, it then expires. Okay, perfect. Another option as well is that like Azure AD is the way to do it if you wanted to use like SDK and want to integrate it into your applications. You don't see the token as such. It gets passed back from an SDK method, and then you pass it in the object into the client you're using. So you don't actually have to go around messing with headers and stuff like that. If you want to implement against the API directly, you absolutely can, and then you can add it onto the header yourself. And then just to complete, if you're using PowerShell, then the mechanism we use in PowerShell is by, I think I showed it earlier, is just, there's a pop-up. Let's see if I can demonstrate this. Have you used PowerShell? Yeah. Okay. Are you familiar with the experience then? Okay, that's fine. It's the Add Azure account. When you run that, it creates a pop-up. Yeah, yeah. Let's go. So switch back. A question from the floor again was, what about if you're running from a Linux machine, and then how does it authenticate? My understanding is exactly the same, in that AD would be configured to either single or multi-factor authentication. The same hoops essentially would have to be jumped through, whether you're on Linux or Windows. So from the server point of view, with the tokens such as that, there's no essential difference. It's using OAuth and REST and so on. There's no difference really between what the client is running and where the client is calling from. The experience might be different from the CLIs and so on, but from an SDK integration, it's conceptually the same. Okay. Hi, question?
So you presented that there's an audit log for the change, but is there any audit log for success and failure? Because when you're introducing new rules, you want to make sure, okay, it's fine, the result is sometimes obvious, but with very tough rules, and you might want to see what has been blocked or rejected, so you have such a feature.
Okay, is the question, to clarify, is the question about logging for the firewall essentially? In terms of what's...
Because that mimics a firewall type of rules in there where you say this segment of the network go to this for the...
Gotcha. And so that if traffic is blocked by the virtual firewall, is there a log of that block? It's not there right now. It is in the roadmap, and we are working on it, but it's not there right now. So what I showed you was the audit logs for the resources and what resources have been changed and by who and when and so on.
Yeah, which is nice, but I mean,
Yes.
it's for a different
Yes.
purpose.
Yes.
To add on top of what Stephen said from the networking team as well, you could use appliances, network virtual appliances, to get that kind of availability as well. So
Yeah, I used to.
Cool. And just for the recording, answer from the floor was that it's possible to use, or would be possible to use virtual appliances to fulfill that scenario, to do the access level logging within the virtual network.
But you're kind of making me having another question. There's like, I know layer 3 is accepted inside Azure, but the virtual appliances, are they capable now of doing layer 2 or it's blocked?
not a layer 2, so you'll have to do like a layer 7 or a layer 4. You'll see the
Yes.
backend as it is like 90 and then you can do it.
And answer for recording is that no, layer 2 isn't supported in Azure, but you can use a layer 7 appliance or so to get that functionality. Okay. So, any more questions? Cool.
One of the things is that whatever we showed right now is used in a lot of our production workloads, which includes stuff like HCN Site, Service Fabric. So we are using the same kind of ARM Resource Manager and NRP, which is a network resource provider, to be able to provision in parallel and in bulk. So it's already production grade, though we are calling it like public preview. We are testing this on really high velocity workloads and high impact workloads. And you must have already seen that we are giving you an amalgam of management services, right from the DevOps model where it's all SDK based,
to a pure play IT pro model, which is entirely based on the portal. And I believe templates are an excellent transition point for moving from IT pro to DevOps and vice versa. Of course, the vice versa is not applicable, but it's a great transition point for IT pros to move to the DevOps model using templates because of the declarative structure.
Cool. Well, thank you all for your time.
Appreciate it.
Good having you. And please do fill out the feedback.